So please subscribe, like, and share this video. Thank you. Good morning, everyone. Welcome to my channel, Professor in Suit. My name is Mr. Akshay. Today we'll be doing grade 12 general EOT. Okay, so this is very important year for you guys, as if you get A plus in this, and as all of your questions are multiple choice, if you get A plus, definitely you will go to college, whichever you choose. You'll get field whatever you want. So focus 100%. Okay, so let's straight away get dive into it. So we'll be doing EOT General for grade 12. My name is Mr. Akshay. So let's straight get dive into it. Question number one. Simplify the rational expression. What do you mean by simplify? Means you need to cancel. Now what you can cancel? Something from up and something from down. You have to cancel. Now to make it cancel, it has to be same. Now which one we need to make it same? Always look for the big term. Now, how many terms you have? You have one term, two term, four terms. So there are four brackets. Out of these four brackets, which bracket is the biggest one? Which has more terms? Not this, not this, not this, this one. So you see, so we'll take something common out of this. So we need to cancel from this bracket. So we'll take something common out of it. Now what is common? Common is something same in both of this term and this term. Now what do you feel it's same in both of this term? X. You see, so the x is same, right? So what I can do, I can take the x outside. So if I take the x outside, what will remain here? 6 I have not touched it, and from this x2, 1x I have taken outside, so 1x is still there. Minus 5, again x is gone, so there is no x, only y. And rest of the brackets will not touch it, it will as it is, it will be as it is. What can you see? You see something up and something down. Looks similar, but it is not same. One minor difference is there. What is that difference? Negative. You see the 6x is positive here, but here it is negative. 5y is negative here, but 5y is positive. So how can we make it same? Easy. Nothing. We'll just take minus out from this bracket. So once you take the minus out, what you will get? Minus x, and this one will become same like the down one. Because once we take the minus out, the sign becomes opposite. Okay. Now you can see the up and the down become same, so we can cancel it out. So what's your answer? Minus x, x plus 2y over x plus y. So which option seems to be correct? The D option. No, sorry, not the D option. See, that's what. See, x minus y, but we have x plus y. So don't make a mistake as I did it. Okay, check for the sign. So here it is plus, here it is minus. So look carefully. Minus x, x plus 2y, x plus y. So in the exam, there is a hurry. You guys do mistake by doing hurry. So don't hurry. Okay, let's go to the next one. Simplify. Same way, we need to cancel, check for the big term. Now, which is the big term? Which has lot of power, lot of numbers. You see this. Okay, so let's try to take something common from here. What can you take? Is there any same term? No. But can I make it same? Now look here. This looks like a formula: a square minus b square. What was the formula for a square minus b square? A minus b, a plus b. Now to change it into that formula, you need to have a square and b square, the entire square. This is entire square, but this is not. So what I can do, x, I can write it as whole square, no problem. But this 9, I can write it as 3 y the whole square. Because 3 square will become 9, correct? And y square is y square over xy over. This again, there is a big over. So this over, what I'll do, I'll just make it over here like this, divide, no problem. 2x plus 6y over x square. Okay. Now this looks like a square minus b square. You see? Okay, like a square minus b square. What can I write it as? A minus b into a plus b. So what this will become? That's your a, that's your b. So a minus b. So x minus 3y and x plus 3y. Okay, over xy. And this divide, I don't like this divide. I want times. So when you make it times, what you will do, you will flip this thing. This will go up and the up will come down. So x square will go up and 2x plus 6y will come down. Okay. Again, this 2x plus 6y will come down. Now can you see something? Let it write together x minus 3y, x plus 3y, and x square you have over xy. From this 2 and 6, can I take 2 outside? Again, I can take 2 outside. Okay. So times 2. If I take outside, it will become x plus 2 is gone. What is remaining? X is remaining. And from 6, if I take 2 outside, divide 6 by 2, what you get? 3. And y will remain. Now, let's go to the cancellation journey. What's the cancellation? So 1x and 1x will get cancelled because you have x square. So if 1x will get cancelled, x plus 3y, x plus 3y will get cancelled. So what remains now? So you are left with x minus 3y times x, because 1x is still remaining, over 2 and y. 2y. Now when you look at the option, be very careful. So you have x, x minus 3y, x minus 3y, and 2y. This option. Understood? Easy peasy. Now, what algebraic method is primarily used to find equation of an oblique asymptote? Now, always remember, when do we use this asymptote and everything? So, whenever you have something like this, oblique asymptote means what? Asymptote which is going obliquely. So, when you will use this, whenever you have the numerator bigger than the denominator. So, whenever you have numerator bigger than the denominator, means you will always use long or synthetic division. Okay, what you will use? Long and synthetic division. Again, let's go back to simplify the rational expression. Again, try to bring something common from the bigger term. Which is the bigger term? Down is the bigger term, but with the bigger power. It's the upper one. Okay, so we'll try to bring something common. What can I take common? You see, x. X square I can take common because x square and x cube, which is the smaller power square. So I can take the x square outside. When I take the x square outside, look what happens. 9 will remain inside. Minus from this x3, x square is taken. So 3 minus 2. What will remain? Only 1. So 9 minus x. And what about this down? Does this look like mod phi 1? Okay, so let's factorize it. Sorry, mod phi 3, my bad. Okay, so x square, you see, mod phi 3. So let's factorize it. What's the first term? For people who are new to it, you can factorize quadratic expression by using mod phi 3. Okay, so try to put the coefficient. No number means 1. What's the next number? Minus 3 minus 54. So what's the answer? You get 9 and minus 6. What do you get? 9 and minus 6. So you get 9 and minus 6. These are the answer. So but when we write it, as you have two answers, you will put two brackets. And when you write, you put x, and you put whatever is the answer you get, you put its opposite. You put its opposite. So if you have plus 9, you put minus 9. You have minus 6, you put plus 6. Okay. Now, can I cancel? Oh, again, 9 minus x, x minus 9. They are same to each other, but only difference is negative. What I'll do, take the negative out. So when I take the negative out, The up one will become same like the down one. Okay, x minus 9, x plus 6. So cancel, cancel. What do you get? Minus x square over x plus 6. Where is minus x square over x plus 6? Okay, that's how you do it. Always focus on the bigger power. That will help you give an idea. Should I take common? What should I do like that? Okay, okay, let's go to the next one. Find a negative coterminal for 35. Oh, what is negative coterminal? Coterminal is something which is at the same angle, okay, but the other side. But if they say negative means it should come negative. Now, let me show you how it is. First of all, 35. Where will 35 come? So that's your 0 degree, that's your 90 degree, that's 180, that's 270, and that's 360. Okay, let me draw down. That's the space. Okay, so you have here. Okay, so that's your 0, that's your 90, that's your 180, that's your 270, and back to 360. Now where will be your 35 degree? First draw the 35 degree. 35 degree will be where? In the first quadrant, so somewhere here like this. Okay, so this will be your positive 35 degree. How you know it's positive? Because you have gone anti-clockwise. Whenever you go anti-clockwise, it's positive. So when you go clockwise, that's your negative. So let's go clockwise. So that will be your negative. So same way, I'll go clockwise. That's negative. How will you find this negative number? Total is what? 360. So from 360 minus 35, how much you will get? 325. Yes, 325. And that too with a minus. Because you're going clockwise. So 325 with the minus. Okay, so that's how you do it. Let's go to the next question. Okay, so let's get back to that question. Okay, so what does this question says? Negative quotient finish. Next, if the degree of the numerator polynomial is less than the degree of the denominator polynomial, what will be the horizontal asymptote? Now, what do you say in that case? Now, everybody remember, now what does the rule says? For you, I want you to remember this rule. Now, whenever this is your numerator and this is your denominator. Now, if the numerator is less than the denominator, let it be d instead of m, it's better d. So if the numerator is less than the denominator, your horizontal asymptote, let me say ha, will be at y equal 0. Okay, what's y equal 0? That's your x-axis. If the numerator is equal to the denominator, that's most case when the upper power is same as the down power. Okay, what do you mean by numerator denominator? I mean the power. Okay, so the power of the exponents power. Okay, the power of the x, power of the y, anything. Now if the numerator's power is equal to denominator power, then the horizontal asymptote will be at y equal a over b. Now what is a? Now suppose your numerator is ax cube, okay, and the denominator over d, and the denominator is bx cube. Now you see, plus 2 and plus 3, suppose. Now you see in the numerator, the higher power is 3, and the denominator, the higher power is 3. Both the power is same, so it comes into this criteria. And if it's same, we have to take its coefficient. So a over b, that will be the answer. Okay. And what if the numerator is bigger than the denominator? Then in that case, no horizontal asymptote. Okay, no HA. Now here what we need, the numerator is less than the degree of denominator. That means the A1. So in that case, what's the answer? Y is what? 0. So Y is 0. This is the answer. Understood? So I want you guys to remember in this way. Let's go to the next one. Which value is not in the domain of the parent reciprocal function? Now here, now what is this? This fx equal 1 over x is a reciprocal function. And it's a parent function. Why you say parent? Means it's the original function. Like x is original variable, you add anything to it like x plus 2, x plus 3, 2x, 3x, then it's not a parent function. The parent function, it's only x, the original one. Okay, the goat. Okay, so same over here, 1 over x, it's the original parent function. So which value is not in the domain? How you find domain? Domain means what? Some value at which it is not possible. That is what value of x. Okay, that's your domain. Domain we deal with x, and range we deal with y. So domain is what values of x. It's not possible. So not possible values of x. Not possible values of x. Okay, now how do you find it? Always look at the denominator. Now here the denominator cannot be 0. Now if the denominator becomes 0, then it straight away becomes infinite. So x is the denominator, that's equal to 0. So that's the not possible values. So that's the answer, 0. What is the value of x for which the reciprocal function is undefined? Again, when it will be undefined? When the denominator becomes 0. Now what's your denominator? This one. So minus 2x plus 5 becomes 0. Solve it for x. Bring the plus 5 here. So it will become minus 5. Divide by minus 2. Divide by minus 2. What do you get? Minus 2 cancels. X will be what? 2.5. Okay. Or 5 over 2. That's fine. That's your answer. Understood? So that's the value of x for which it becomes undefined. Simplify the rational function. Again, we came back to the same function. So you understand most of the questions are simplifying. Okay, so always look at the big power. Which is the big power? Straight away, when you remember this concept, it's easy for you to simplify. Now you see this is the big power, right? Try to take something out from here. So if I take something out, what will I get it? X square I'll take. What something out? Something which is same. So x square and x is same, right? But which is the what is the power small? What is the smaller power? X square. So I'll take the x square out. So what you will have? 5. From x3, x2 is gone. So only x is remaining. Plus from here everything is gone. So no number means 1. 1 will remain. Don't put 0. 1. Also something I can see. 7y minus 3x. And here 3x minus 7y. Both are same but opposite inside. You see? So what can I do? Take the minus out. That's our infamous step. You take the minus out and it becomes opposite. And rest of the becomes same. 3x minus 7y. Now cancel it out. So 3x minus 7y, 3x minus 7y cancel. X square, can I cancel anything? No. So you still remain with minus outside 5x minus 1, and down you will have x square 5x plus 1. Do you have any options with this? Yes. Understood? That's how you do it. Don't try to cancel this 5x minus 1 with this, okay? Even though you have minus outside, if you want to take it inside, it will become opposite, okay? It will not become same like denominator, so you don't cancel, okay? 5 minutes, okay. Let's go to the next question. Check the unit circle. Point this on a unit circle lies in which quadrant? Oh my god. Now look, I'll give you a trick to find. Now, what are the quadrants? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. Now, here it is plus plus. Here it is minus plus. Here it is minus minus, and here it is plus minus. So, check what is this option? This is minus plus. So, minus plus is in which quadrant? Straight away. Quadrant 2. Easy. This way you can remember. Okay. Now you will tell me, oh, Mister, how did you get this plus plus in the first quadrant? You see, in the first quadrant, you have this x and you have this y. Now, what is this x? This is plus, and this also plus, right? So plus plus x first, then y. Same here in the second quadrant. Let me take another color. In second quadrant, if I take this one, it's negative minus, but the up one is still plus. So first x, then y. So minus plus. You see? In third quadrant, it's minus and this also minus. So minus, minus. And in the fourth quadrant, plus, minus. Always take x first, then y. Understood? Easy? Okay, let's go to the next one. A rational function has an oblique asymptote when what? Just now we did it up. When the numerator power is more than the denominator. The numerator power is more than the denominator. So, and also the numerator power has to be 1 degree more than the denominator. So, if you say, what's the option? Degree of numerator minus the degree of denominator equals 1. So, that's one of the option. That might be correct because numerator minus the denominator is equals 1. Means numerator is bigger than the denominator by 1 degree. So, that's the option. That's correct. What about the rest of the options? Let's check more. Degree of denominator greater, wrong. Degree of denominator minus numerator, wrong. No. So only the option is correct first one. Okay. So for oblique asymptote, always remember numerator should be bigger than the denominator and the numerator should be 1 degree more than the denominator. So if I minus numerator minus denominator degree, I should get 1. So if the numerator degree is 3, the denominator degree should be 2. Okay, so it should be 1 more. Okay, so let's go to the next one. Which type of graph is produced by the parent reciprocal function? Now, what is this reciprocal? Now, what do you feel reciprocal? Okay, so reciprocal is like this. Okay, so a value at what? X equals 0, it will not be possible. So x equals 0, it's not possible. So here is your x 0. Okay, so x equals 0 is your this y axis. So you can never touch the y-axis. Okay. So x equals 0 can have values like this. Okay. So it will go like this up. Okay. So in this way it will go and also it will go in this way. Here also it will come from here, it like this. Okay. So that looks like which? It looks like hyperbola. Okay. So it's not a parabola, it's hyperbola. So that's your answer. Okay. So this is your part one. We finish. Let's go to the next question afterwards. Thank you for watching. Masalama. Bye bye.